Hello everyone and welcome back. We are doing logarithms. I hope you've practiced and revised whatever we've done. I'm going to do a quick recap up to whatever I have showed you and I've proven to you that when log of a number a is taken to a base b and the value is c, this is the logarithmic relationship between a, b and c. This logarithmic relationship can be changed to an exponential by saying that b raised to c gives you an a. Then we did change of base theorem. If you are taking log of a number a to the base b, then what we can do is, if you don't want the base to be b, you want it to be something else, you can use change the base theorem and change the base from b to anything. How? Write it as log a divided by log b and then make the base anything you want. Anything you want. But whatever you make it in the numerator, same base has to be in the denominator. Then we did log changes multiplication to addition. Log of a into b is log a plus log b. Log changes division to subtraction. Log of a minus b is log a minus log b. Log of a by b is log a minus log b. Log of a raised to b, the power comes in front and becomes b log a. A few standards, and that is log of a number a to the same base is always 1, or log of any number to the same base is always 1. Log of 5 to the base 5, log of 7 to the base 7, log of 3.5 to the base 3.5 is always 1. Log of 1, no matter what the base is, it's always and always 0. Log of 0, no matter what the base is not defined. And log of a negative value, no matter what the base is a value which is not defined in mathematics. After having done this, I want to step into the next part. But one last thing, I have showed you how to take log in your calculators. I hope you remember that, which is press the root sign 15 times, minus 1, divided by 0.00007027, and that is going to be the log of that value. How do you take log? Log of a number is in two parts. One part is called the characteristic, the other is called the mantissa. The characteristic you decide, the mantissa you get from the table. How do you decide the characteristic? Characteristic is number of places before the decimal minus 1. For the mantissa, look at the number without the decimal. After you look at the number without the decimal, you look for the first two digits in the first column, third digit in the next column, and the fourth digit, if any, in the mean difference column. Add the two, and that is your mantissa. So what I'm going to do is, very quickly before I begin, I'm going to show you or recap how to take a log of a number, because after that I'm going to build on it. So to begin with, log of let's say the number, any value you can take. Let's say I'm taking 463.2. Now, mind you, in our log tables, we can only take logs to the base 10. In our calculators also, we can only take logs to the base 10. How do you take a log? There are three numbers, digits before the decimal. Minus 1 is 2. Point. Look at the number without the decimal. Without the decimal, it is 4632. So come to your log sheets, the log part of the sheets. We are looking for 46, in that we are looking for 3, in that we are looking for 2. So 4632. Pick up your scales and you have 46 is going to be somewhere here. In 46, we are looking for 3. So 46, 3 is going to be 6656. 3 right here, you can see here also 6656, and in that we are looking for a 2. 2 is going to be 2. So let me do one thing, let me zoom this a little and show it to you as to how it works, so that you are also confident that that is the log. So if I zoom this a little, there you have it. 46, 3 is 6656. So let me put that in my calculator, and that is 6656 plus, we are looking for 2. 2 is 2 itself. So the 2 in that is 2 itself. So when you add the 2, you get 6658. So the answer is There you have it, 6658. So this is going to be 2.6658. Wow, that is a little too much of me. Let's come back, 2.6658, correct? I'm going to show it to you that in the calculator also we would have gotten the same answer. How would you do that? What is your number? It is 463.2, correct? Press the root sign 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, minus 1. Divided by 0.000070271. 2.6659, isn't that the closest you have? 2.6658. So you can take logs to the base 10 in your calculators also. Fine. So this is the log of that value. After doing this, what you could also say is that if you want to check, then what I'm trying to say is that 10 raised to 2.6658 should give you a 463.2. So 10 raised to a 2.6658 should be 463.2. So what I'm going to do is I'm going to show it to you in my phone, because like I said, you can't raise these values in your regular calculators. So first for all, change your normal calculator to a scientific calculator, and then you want to 10. That 10 has to be raised to. I'll zoom this a little for you if you want. So the 10 has to be raised to. Where is the raised to? Here, x raised to y has to be raised to 2.6658. What do you get? You get a 463.23354 and so on. 463.23. So that also tallies, which means it is correct. That's it. Those are the basics I want to recap. So now after this, I want to elaborate on whatever we did and continue. So log of 463.2 is 2.6658. Is that correct? I'm going to start this again, but slightly differently. What if I ask you what is log of 4632? So you will say there are 4 places before the decimal. Am I correct? Yes. 4 places before the decimal will be 4 minus 1, which is 3 point. What is the number without the decimal? The number without the decimal is 4632. Correct? So if the number is 4632, the mantissa will remain the same, because I just looked for the mantissa for 4632 and it is 6658. Because in 46 3 was 665.6 if I'm right, and in that I added the mean difference of 2, which was 2, so that came out to be 6658. Fine. What if I ask you the log of 463.2? How many places before the decimal? 2. Minus 1 is, 3 places before the decimal. Minus 1 is 2 point. Without the decimal, the number is still the same. So the mantissa remains the same, which is 2.6658. What if I ask you the log of 46.32? How many places before the decimal? 2. Minus 1 is 1. Point. Can I say without the decimal the number is still the same? So the mantissa still remains as 6658. What if I ask you the log of 4.632? How many places before the decimal? 1. There's 1 place before the decimal. Minus 1 is 0. Point. Can I say without the decimal the number still remains the same? Then is it fair to say that the mantissa will still remain the same? And the mantissa will be 6658. But what if now I ask you the log of 0.4632? Now, the moment I write something like this, students immediately jump and say, how many places before the decimal? Everybody says one place before the decimal. Sorry. If it is a 0 to your left, it is not a place to the decimal. So listen to what I am saying carefully. Listen to what I am saying very carefully, because now I am going to change the way you count the numbers before the decimal. I'm going to repeat this. Pay attention to whatever I'm saying, because I am now going to change the way you are going to count the numbers before the decimal. Step 1. Write down your numbers. What do you want me to check for places before the decimal? Well, let's say I want you to check 63.49 and tell me how many places before the decimal. Easy, sir. What is the problem with 63.49? I agree, but I want you to change the way you do it now. Meaning, step 1, write the number without the decimal. How do you write the number without the decimal? 6349. Perfect. Where is the decimal currently? Here, which means it's here at the 3. Correct? Don't look at this number. Look at this. When I look at only this number, where does the number start from? Well, the number starts from 6. 6349. Perfect. Do me a favor. Put a decimal where the number starts. Okay. So I've put a decimal here. Fantastic. Your original decimal is here and you have to reach here, which is before the 6. So your original decimal is here, and now the new decimal that I've put is here. You have to reach, you have to jump, you have to hop from this decimal to this decimal and tell me in how many hops do you reach here. Okay, so when I start from here, this is hop number 1 between the 6 and the 3, and this is hop number 2. I took 2 hops. If you took 2 hops, the number of places before the decimal is 2. I repeat, if you took 2 hops to the left, the number of places before the decimal is 2. I understand, sir, but I don't know why we are doing this. It will make more sense when I come into places where it's not that easy. Let's take one more example. What if I ask you how many decimals are there? How many places before the decimal in 463.917? Again, write the number without the decimal. Without the decimal, it is 4634917. What is the leftmost value? The leftmost value is this 4. Okay, combine the two and write it together. 4634917. This is the actual and this is what I have put. You have to start hopping and reach here, and those will be the number of places. 1, 2, 3, 4. 4 hops, 4 places before the decimal. Sir, I agree. Why are we doing this? Humor me, be patient and follow. Let's take another example. 639.463. Okay, this is your original decimal. Without the decimal, the number is 639463. Let's put a decimal here, the leftmost. I have to go from here to here. I have to hop to the left. So, if it is 639463, this is my original decimal. This is the extreme leftmost decimal. How many hops? 1, 2, 3 hops, which means there are 3 places before the decimal. But sir, that I could have counted also. Agreed. So now let's take a standard number and keep shifting the decimal only on that number. Like for example, 43632. Where is your current decimal? Well, there is no decimal, which means the decimal at the rightmost. Okay. This is the number without the decimal. Put a decimal on the leftmost value. Okay. Combine the two. This is my actual. This is the leftmost. How many hops? 1, 2, 3, 4 hops. And that is why 4 places before the decimal. Mind you, I am not writing the characteristic. I am writing down how many places before the decimal. Let's come to 463.2. Okay, this is where the actual decimal is. 4632 is the number without the decimal. Let's put the decimal at the leftmost, standard leftmost. And I have 4632. This is the actual, this is the leftmost. 1, 2, 3. 3 hops, so 3 places before the decimal. What if it is 46.32? Well, without the decimal, it's 4632. Leftmost is here. 4632. This is your actual. This is the leftmost. From the actual, if I come to the leftmost, I have to go 2 hops to the left. 2 places before the decimal. 4.632. Well, same. The actual is here. Without the decimal, it is 4632. Put a decimal on the leftmost. Combine the two. 4632. This is the actual. This is the leftmost. Hop, 1 hop. And that is why there is 1 place before the decimal. And this is from where it starts becoming fun. Now when I ask you how many places before the decimal in 0.4632, you will stick to the same logic that I told you. Write the number without the decimal. Without the decimal, the number is 4632. Put the decimal to the leftmost. Combine the two. Well, both are the same. 4632. The actual is also this and the leftmost is also this. Did you hop in any way? No. If you didn't hop in any way and your actual and the leftmost is the same position, it means there are 0 places before the decimal. And now I'm going to continue in the exact same manner. What if I ask you how many decimals, how many places before the decimal in 0.04632? Step 1, write the number without the decimal. Without the decimal is 4632. Put the decimal to the leftmost part. Combine the two. When I combine the two, 004632, and I want you to pay attention now. The actual decimal is this. And my leftmost decimal is this. Is that right? Usually what would happen is actual to leftmost was a left hop. Actual leftmost, left hop, actual leftmost, left hop, actual leftmost, left hop, actual leftmost, left hop. Now the actual to the leftmost is not a left hop, it's a right hop. When you are going left, it is 0, 1, 2, 3, 4. 0, 1, 2, 3. 0, 1, 2, 0, 1, 0. Because no hop. But now if you are hopping right, aren't you hopping right to go to the rightmost? Yes. To the left is positive counting, to the right is negative counting. So 0, and when you hop to the right to go to the leftmost value, it is a -1 hop. I am going 1 hop behind. What if I ask you 0.004632? Let me write that properly. 0.004632. First write it without the decimal. 4632. Correct? Put a decimal at the leftmost. Combine the two. 0.004632, and this is the leftmost. Remember, you always go from the actual to the leftmost. Is that right? This is my actual decimal and this is the leftmost decimal. Is that right? How many hops? 0. I am hopping to the right. So negative counting, -1, -2. So -2. Let's come here. And the next is 0.004632. Again the same. Write the number without the decimal. Put the decimal to the leftmost. Combine both 4632. Put your leftmost decimal. Hop from the actual to the leftmost. Actual leftmost would be 1, 2, 3. So can I say a -3? Yes. And that is how you count the number of places to the before the decimal. Or let me make this simple for you if you understand this. And now if you understand, you don't have to do all of this all the time. If you understand this, fantastic. But you don't have to do this all the time. Suppose I ask you how many places before the decimal in 0.00691. This is your actual decimal. From the actual decimal, start going to the leftmost value. What is the leftmost actual value? 6. Then this is 1, 2. But I am going to the right, so -2. What if this was 49.63? Start from the actual and go to the leftmost. The left here is 4. And I am doing a left hop, 1, 2. So it's +2. Here reverse is -2. Here ahead is +2. Then let's come back. What was I doing? I asked you how many places before the decimal. Sir, I am already at the leftmost place. There is no further left. So am I hopping in any way? No. Which means there are 0 places before the decimal. So let me do one thing. Let me do this on a fresh page with the table. So 0.4632. Column number 1, number of places before the decimal. I am at the decimal already, no hops. So 0 places before the decimal. What if it is 0.04632? I have to go to the leftmost, but the leftmost is on the right. So I have to do a reverse hop and I reach the 4. A reverse hop will be -1. What if it is 0.004632? Here, I have to reach here, but I am going reverse. So -1, -2. -2 is the number of places before the decimal. 0.004632. -1, -2, -3. -3 is the number of places before the decimal. Done? Then the next thing that I want to find is the characteristic. What is characteristic? Characteristic is number of places before the decimal -1. Okay. How many places before the decimal? 0. -1 is -1. How many places before the decimal? -1. -1 -1 is -2. How many places before the decimal? -2. -2 -1 is -3. And how many places before the decimal? -3. -3 -1 is -4. And this is my characteristic. So, number of places before the decimal is 0. -1 is -1. Number of places before the decimal is -1. -1 -1 is -2. Number of places before the decimal is -2. -2 -1 is -3. Number of places before the decimal is -3. -3 minus 1 is -4. We now come to the mantissa. See, without the decimal, all the values are the same. So the mantissa remains the same, which I've just found some time ago, 6658. So mantissa is going to be 0.6658, 0.6658, 0.6658, 0.6658. So when I bring the two together, log will be -1.6658, -2.6658, -3.6658, and -4.665. And this is the log of 0.64632, 0.04632, 0.004632, 0.000462. Now that we found this, let's just check for sure if this is correct, which means I have taken the log of, let's say this, 0.04632 to the base 10, and the log is -2.6658. Okay, which means that if 10 is raised to a -2.6658, I should get a 0.04632. 10 raised to a -2.6658 should be a 0.04632. Yes, well, let's then check if this is correct. Let's come back to our cell phones, because this raising can only be done in a cell phone. It is 10 raised to, so x raised to I in my calculator. Your calculator might have the caret sign, raised to a negative of, 10 raised to a negative of 2.6658. What do you get? What? 0.02158. No, I'm looking for a 0.04632. Have I made a mistake? Let me check. Let's go back and say this is the number. Number of places before the decimal is 0. -1 is -1. And mantissa is this. And log is characteristic plus mantissa. Yes, that is exactly where you are making a mistake. And the mistake is log is characteristic plus mantissa. Well, sir, I've done that only. No, you've not done that. See, if this was 1, then it is correct. Because 1 plus 0.6658 is 1.6658. -1 plus 0.6658 is not -1.6658. Is a mistake that you are making. Log is characteristic plus mantissa. Characteristic here in this case is -1 plus the mantissa is 0.6658. You know what that becomes? What that becomes is 0.6658 -1, which is 0.3342, but negative. So this is -0.3342. So the log here is not -1.6658. The log here is -0.3342. What will this become then? This will become -1.3342. What will this become? This will become -2.3342. What will this become? This will become -3.3342. Because log is characteristic plus mantissa, and because the characteristic is negative and mantissa is always positive, when you add the two, they actually subtract. So if that is correct, then the log of 0.04632 should be -1.3342. Yes. Can I check that? Yes, go ahead. log of 0 point or log to the base 10 of 0.04632 should be minus 1.3342, which means that when 10 is raised to a minus 1.3342, I should get this. 10 raised to minus 1.3342 should give you a 0.04632. Let's check if that is correct now. Come back to your cell phones and let's again shift it to the calculator, scientific calculator mode. 10 is raised to, what is raised to? 1.3342, but negative. What do you get? You get a 0.04632. Is that right? Perfect. So now that's correct. Which is where I am going to introduce you to a new concept called the bar concept. Now, what do you mean by the bar concept? So first, let's just get two meanings of the word bar out of your head. Number one, resto bar, not a resto bar. This is not a restaurant where you go to eat, not what I'm talking about. Number two, the bar that we use in mathematics where there is a recurring decimal. Like for example, if you remember, बहुत पहले, बहुत पुराने ज़माने में स्कूल में किया था. So if this is 446 point, let's say 37373737, we don't write it this way. We write it as 46.37 bar. What does that represent? That the 373737 is recurring. This is also not the bar that I'm talking about. Here I'm going to introduce a slightly different bar concept. And the concept is, number of places before the decimal is 0, right? Then characteristic should be minus 1? No. We don't write the characteristic to be minus 1. We write the characteristic to be bar 1. What does that represent? That represents that the 1 is negative. Minus 2 will be written as bar 2, represents that 2 is negative. Bar 3, bar 4. And now we combine these two for the log and write this directly as characteristic plus mantissa, and that is bar 1.6658, but the bar represents that only the 1 is negative, the 6658 is positive. So if I tell you that I am writing bar 1.6658, I will know that this splits as bar 1 plus 0.6658, in which the bar 1 is negative. So minus 1 plus 0.6658. If you've done mathematics 11th and 12th, you must have done this, the bar concept. I'm going to bring everything together and finish it off so that I can then move into questions finally. Number of places before the decimal. Till there are actually places before the decimal, we do a left count till we go to the end, and that's the number of places before the decimal. But what if there is no left count? What if to the left hand side there are no numbers? The last number is actually way ahead of the decimal. Example, what if the number is 0.006142? Okay. Now when you count the number of places before the decimal, from the decimal you have to go to the actual left. Without the decimal, this is the actual left. The actual number is 6142 without the decimal. So I have to reach here, and that is 0, 1, 2. 2 hops but to the right, and because it's 2 hops to the right, I am going to say that it is minus 2 hops. So number of places before the decimal is minus 2, minus 2 minus 1 is minus 3, but I won't write it as minus 3, I will write it as bar 3. Point. I will write down the mantissa. How? Without the decimal, the number is 6142, which means in 61 I am going to look for 4, in that I am going to look for 2. Let's come to 61. This is 61. Under 61 I am looking for 4. Is 7228? In that I am going to look for 6142. So 7882. In that 2 1. So it's 7883. So the value is 7 7,883. So it is 7,883, where this represents that the 3 is negative and this part is positive. So to simplify further, I'm going to say that this is my bar 3 plus 0.7883, which is minus 3 plus 0.7883. Minus 3 plus 0.7883 is, I'm going to do reverse, positive and then negative. So 0.7883 minus 3. 0.7883 minus 3, and the answer is minus 2.2117. So this is minus 2.2117, and this is the log to the base 10 of 0.006142. Not sure? Check if 10 when raised to minus 2.2117 gives you a 0.006142. Let's go back to our phones, and that is 10 is raised to a 2.2113, but this is negative. What do you get? You get a 0.006142. They have 6147, but that's okay. This is the closest I'm going to get. Sir, can we do the same in the calculator? Yes, I've told you this. You can take logs to the base 10 in the calculator also. What do you want to take a log of? I'm going to take a log of 0.006142. Root sign 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, minus 1, divided by 0.000070,271. It's minus 2.114. Isn't that correct? Yes. And that is how you take logs of numbers where there are actually no place to the left of the decimal. With this, we can now begin with the chapter learning curve. Before that, a very quick recap of whatever we did. Well, what we started off is logarithms. Why, how, when, where is none of your business right now. All your business right now is understanding logarithms. So, log of a number has two parts. One part is called the characteristic, the other is called the mantissa. The characteristic you decide, the mantissa comes from the log table. Characteristic is number of places before the decimal minus 1. Mantissa is look at the number without the decimal, the first two digits in the first column of the log table, the next digit in the third digit in the next column, and the fourth digit, if any, in the mean difference column. If there are more than 4 digits, at your level we can't do it. We convert it to a 4-digit number. After doing that, logs. Log rules. Log of a to the base b is c, which means b raised to c is a. Log a to the base b, change of base theorem. Log a divided by log e, both bases x. You can write it anything that you want. Log of a into b is log a plus log b. Obviously, the same base carries ahead. Log of a by b is log a minus log b. Log of a raised to b is b log a. Log of the number to the same base is 1. Log of 1 to any base is 0. Log of 0 to any base is not defined. And log of a negative to any base is not defined. After this, we begin with a new concept, and that concept is called learning curve. What is learning curve? What does learning curve mean? Well, quite literally, when the word learning comes in, there is learning involved. What kind of learning? Well, we are talking about how you learn doing something and the time related to doing it. Example, let's say you've started studying for a new course. Let's say mathematics पढ़ना चालू कर दिया है और अभी पहली बार पढ़ रहे हो, वीडियोस देख के या लेक्चर्स अटेंड करके हो चुका है. अब आप प्रैक्टिस करना चालू किए हो खुद से. लेट्स से ऑन एन एवरेज एक आध चैप्टर में, एक चैप्टर है जिसमें बहुत बड़ा चैप्टर है, लेट्स से परम्यूटेशन कॉम्बिनेशन टाइप चैप्टर है, या फिर आपका कोई कॉस्टिंग वाला चैप्टर ले लो, कोई भी चैप्टर. बड़ा चैप्टर है और पूरे चैप्टर में सब मिला के लेट्स से 50 क्वेश्चंस हैं। अगर मैं ये चैप्टर पहली बार कर रहा हूं, पढ़ाते वक्त तो मैंने ध्यान दिया था, अब मैं खुद से कर रहा हूं। दिस इज द फर्स्ट टाइम आई एम डूइंग द चैप्टर माई सेल्फ। हाउ लॉन्ग विल इट टेक फॉर यू टू डू 50 questions? So you do your own calculation. You say, sir, once I sat down for 1 hour, and in 1 hour I did 5 questions. Oh, so in 1 hour you did 5 questions. Then to finish 50, I will have to sit how many hours? Let's say I will have to sit 10 hours. So to finish these 50 questions, I took a total of 10 hours. So if my friend asks me, have you done this particular chapter? You will say yes. Is it easy? Easy है क्या? हाँ, easy तो है। मेरे को approximately 10 घंटा लगा था जब मैंने पहली बार किया था। अब पहली बार करके हो चुका है। Cut to after 2 or 3 months, you say, oh, this chapter I had done first at the beginning. I haven't touched it now. Let me do it again. So this is my second attempt to the same 50 questions. My question to you is, and you will agree with this, will it take the same 10 hours for you to do this job? No. Because a lot of questions which initially I was struggling to get a solution, now when I look at the question, I know what the solution is going to be. So I immediately start the working. So I will definitely take lesser than 10 hours because I have learned from my previous experience, and the time taken could be only 8 hours. Cut to the exam is in a month, and now I want to practice the chapter again. The same questions, I have already done them twice. All I need to do is revise them once again. And now when I'm revising them once again, will I take 8 hours? No. I will take lesser than 8 hours to do this job. How long will you take? I don't know. All I know is lesser than 8 hours. Let's say I finish it in 6.5 hours. What is happening? As and how you repeat something, as and how you repeat the same work, the time taken for you to do it keeps reducing. And that is nothing else but learning. With every attempt of doing the job, you learn it better and you start doing it better. And this applies everywhere. Everywhere. When you go to a new school or a new college, as simple as you go to write your exam, and the center is not your college. If the center is not your college, day one, if the exam is at 12 p.m., 12 baje exam hai. There are a lot of people who leave the house at 9:30 only. Day one, they leave the house at 9 a.m. Why? Because I don't know how long it will take for me to reach there. This is a new route. This is the new attempt of me going there. Day one, you travel, you make a few mistakes. अरे प्लेटफॉर्म के स्टार्ट से निकलना है अपन को, सो नेक्स्ट टाइम आगे वाले डब्बे में चढ़ते हैं, पीछे वाले डब्बे में नहीं चढ़ते. रिक्शा स्टैंड इज एट दिस प्लेस, मैं फालतू में इतना घूम के गया. देयर इज अ बस स्टैंड राइट नेक्स्ट टू द प्लेस. ये बस डायरेक्ट कॉलेज के सामने जाता है, ये बस थोड़ा दूर उतारता है. एंड एज एंड हाउ यू कीप लर्निंग, you get a better idea of the time estimate because you learn. So if day one, it took 2 hours for you to reach the college, the last paper is, let's say, the 10th paper, it will not take 2 hours. Because you've learned how to travel well, it will, let's say, finish in 1 hour. And like I said, this applies everywhere, whether it is learning, whether it's literally learning something, or whether it is making a table or a chair, or whether it is as basic as cutting vegetables, as basic as cooking. If today you decide that lockdown hai, everybody is making dalgona coffee, why not I also do it? क्योंकि जब तक हर एक जन एक dalgona और एक केक नहीं बना लेता, ये पैंडेमिक खत्म नहीं होने वाला. So you decide to make a cake. The moment you enter the kitchen, your mother or whoever in the house cooks. I don't want to be a sexist, so whoever in your house cooks, could be your dad, could be your mom, anyone, will give you a very long stare from top to bottom, wondering, what are you doing here? If you are here to eat. If not, then you are not here to do anything else. But yes, you are not there to eat, you are there to make coffee. Now when you reach there to make coffee, the first question is, अपन कॉफी रखते कहाँ हैं? अपन चीनी या शक्कर रखते कहाँ हैं? अपना दूध कहाँ होता है? And when you start asking these questions to your parents, that is when the entire lecture about how you are irresponsible in life and how do you not know in your own house कि शक्कर कहाँ रखते हैं and all that begins. Whether it is, if you decide to make a cake, the first question is, मम्मी आटे वाला डब्बा कौन सा है? And that is where it begins. You don't know in your own house where these utensils are or where we keep what. Anyway, my point in saying this is, if you are cooking for the first time, let's say to make entire dinner from start to end, maybe it's only for you, not for anybody else. बस एक जन के लिए पका रहे. Maybe you enter the kitchen at 7 and you walk out at 10. Let's say you took 3 hours to cook. Now, let's say you are staying alone for 1 year. After 1 year, will it still take 3 hours for you to cook? No. You will finish the same job in, let's say, 1 hour or 1.5 hours. Why? Now you've learned how to do it. Now you are efficient how to do it. Now you know what is kept where. You know किसमें कितना पानी जाता है. You don't need to read up on anything. You don't need to call anybody up. You don't need to ask anything to anyone. You have your own experiences that I have told you how to do the job. When you repeat something over and over again, the time taken for you to do the job reduces because you become more and more efficient in doing that job. And that is where learning curve comes into picture. Everybody has a way of learning. Everybody has a rate at which they learn. Even we say this. Usko thoda time lagega. He is a slow learner. So somebody who's a fast learner picks up things quicker and they become more efficient quickly, so they take lesser time to do it quicker. Learning curve as a concept is applied everywhere, whether it is the field of arts, science or commerce. It is applied everywhere from production to right from economics to everywhere. Everywhere learning curve applies. It's studied in different ways, but the baseline remains the same. Some study it as a time curve, some study it as an experience curve. Everything remains the same. You must have, if you have ever attended an office, or you must have heard this from people saying that अरे ये काम करवाना है, वो उससे करवा ले, उसको आता है. आपको वो काम करने के लिए 10 घंटा लगता है, उसके पास चले जाओ, he will finish it off in 1 hour. Why? Because that person is doing it for 5 years. He or she has learned how to do it. He or she has experience in doing that job. So let me ask you, whenever you join an organization and you are working for an organization, let's say you worked there for 5 years, you want to now quit. So you put your papers down. After you put your papers down, the first thing that happens is a negotiation where the HR sits you down and asks you, why is it that you are quitting? So you give them a reason why you are quitting. Sometimes what they do is they ask you, what is the opposite organization paying you? Now, if you tell them that, let's say the opposite organization right now, my pay package is 3.5 lakhs and the opposite organization is ready to pay me 4.5 lakhs. Sometimes your HR will match this. Sometimes your HR, if he or she thinks that you are worth, they might up this also. They might say, I'm giving you a 5 lakhs, stay here. My question is, why are they not letting you go? Why are they raising your salary and asking you to stay here? You know why? Because if you go and if I hire somebody in your place, I probably might pay them the same salary, but that person will not be able to do the same work that you are doing. You have been working in this position for the last 5 years. You have learned how to do this job. You are efficient in doing this job. Aaj agar, if I give you 5 files to finish the work, maybe these are tax returns, maybe I'm asking you to audit them, whatever it is. If I give you 5 organizations and I ask you to finish it, maybe you will finish the job in 5 hours because you know ye लेटर चाहिए तो किसके पास जाना है. इफ आई वांट दिस सिग्नेचर, हु डू आई गो टू. इफ आई वांट दिस वेरीफाइड, वेयर डू आई गो टू. वेयर डू आई गेट डन, इन विच सॉफ्टवेयर, व्हाट सॉफ्टवेयर विल गिव मी व्हाट डेटा. But when I hire somebody else in your place, that person will not have the experience in working with us. And that is why what I will have to do is I will have to train them. I will have to teach them. They will learn the process first and then start becoming efficient. And that process in which they are learning, they are a liability to me. They are not making any money from me, but they are actually eating up my resource, eating up the time of other people in the organization by asking them, अरे ये कैसे करना है, मेरे को नहीं आता है, वो कैसे करना है, जरा बताना. And you are paying them for nothing. That is why a lot of times they ask you to wait. A lot of times if you quit, what they try to do is they try to hire somebody from your organization itself in that place. Why? Lesser learning. That person knows hierarchy, that person knows everyone, that person knows where to get things done, how. And that is why it is better to hire a person from the same organization than hire somebody else from outside. How are we going to apply learning curve, or how are we going to use learning curve in our costing? Well, then let's take a costing based example. Let's say you want to get chairs made. So you have a dining table, and these chairs for the dining table are very old chairs, and now they are cracking from one place to another, they are shaking. So you want to make new chairs. Your dining table is a 4-seater dining table. And now you have seen these chairs online and you want to get exactly those chairs made. So you take a picture of those chairs and you go to a market where they make chairs. You go to the first workshop that you see. You enter the workshop and there is a person sitting, जो owner है उस workshop का, and you ask that person that, sir, I want this chair. Can you tell me how much will it cost for me for this set? The person immediately gets up and goes to your laborer that is sitting there. There are 2 costs involved, the laborer says. One is the material cost and the other is the labor cost. Okay. So you divide the cost for the 4 seats into 2 parts. One is material and the other is labor. The person there says that to make these 4 chairs, per chair you will require 5 feet of wood. And I will require approximately 10 hours of time. So you immediately start doing the calculation. And your calculation is 5 feet of wood for 1 chair multiplied by 4 chairs. 20 feet of wood. The wood quality that this person is looking for is at the cost of 500 rupees per feet. 5 2s are 10 and 3 zeros. So it is going to cost me rupees 10,000 for material. Let's go to labor. Now you say that one seat will take 10 hours. I need 4. 4 tens are 40 hours. What are you paying the laborer? Well, what I am paying the laborer is on an average of 100 rupees per hour. So at 100 rupees per hour, 40 into 100 is 4,000 rupees on labor. The total cost of making these 4 chairs is 10,000 plus the 400, and that is plus the 4,000, which is 14,000. You have a standard policy of quoting a 10% profit. So this is your cost plus the 10% profit is equal to 14,000 plus another 10% is 15,400. So you tell me that these 4 chairs, sir, will cost you 15,400. Now, Indian mentality, I will not buy in the first shop that I have. I will obviously go around because there's an entire market. Why not ask everyone? I go to the next shop. I go to the next shop and tell the person the same thing. This is the chair I want to get done. Can you tell me how much will it cost for me to get that chair done? Now that person also starts doing a calculation, but this is a person who is done costing. This is a person who's done cost management. He understands learning curve. He goes to the laborer or the worker in his organization and tells him or her that, see, this is the chair that I have to get made. That person says the same thing. That person also says that one chair will require approximately 5 feet of wood. So you say, okay, again material is 5 feet. 5 feet for one chair into 4 is 20 feet. And this guy is also buying wood from the same vendor. So it is still going to cost this person 500 rupees a feet. So that will come to 20 into 500, which is 10,000 rupees on raw material. Now the laborer says that, sir, I will require 10 labor hours for the chair. But you know that this laborer is a good laborer, and even though he or she might take 10 hours to do the first chair, they will not require 10 hours to do the second, because he or she is a learner and a fast learner. If they take 10 hours to do the first chair, they will not take 10 hours to do the second. They might finish the second in 8 hours. The third chair, they might finish in 7 hours, and the fourth chair, they will finish in 5 hours. The total time taken for the 4 chairs is 8 plus 7 is 15, plus 5 is 20, plus 10 is 30. So the total time required for the 4 chairs is not 10 into 4, which is 40 hours. It is 30 hours understanding learning curve. This person is also paying the laborer same 100 rupees an hour. So it costs 3,000 rupees on labor. The total it costs is 10,000 plus 3,000, which is 13,000 or 13,000 is the cost price. This person also has a standard 10% profit policy. So on the 13,000, he is quoting a 1,300 rupee profit, which is 00341 or 14300. Isn't this person quoting a lot less than the previous one? The previous person was quoting a 15,400, while this person is quoting a 14,300, which is 1,100 less than the previous one. Why? Is this person suffering a loss? No. This person is gaining a profit This person is gaining a lot more than profit. But what he or she doesn't understand is, because they don't understand learning curve, they fail to estimate the cost. And that is why this person gets the job. Another place where learning curve is also very important is, and which I have done with you, but we've not done it in the learning curve perspective. If you are a CA final student, CA final has learning curve, and they have those applications also, and that is calculating capacity. Sir, we've done capacity. I agree. But you know how we've done capacity? One unit takes let's say 10 hours. Then if I'm making 300 units, then I will take 3000 hours. But that is not. Learning curve capacity doesn't work in the same way. If I want to take an order for 1 month, or a month's order is what I have to decide. And for one laborer, I have one laborer working 5 hours every day. Well, he or she work for 8 hours, but 3 hours they are doing other things. 5 hours every day, working for 5 days a week for 4 weeks is a total of 100 hours. So what I try to do is I take orders only for 100 hours. I don't take orders for more than 100 hours because I know this person can only work for 100 hours. So if I get a table order where the person says that, sir, I want to get this done. How many can you make in 1 month? Well, you show it to the laborer and the laborer says making one will take 10 hours. Then you will say, oh, then I can only make 10 items because 10 into 10 will be 100 hours. Done. This person can only make 10. No. If you understand your worker well and if you understand learning curve, what you will realize is the first unit he or she will make in 10 hours. The second unit will not take 10 hours, will take lesser than 10 hours. The third unit will take lesser than that. The fourth unit will take lesser than that. The fifth unit will take lesser than that. The sixth unit will take lesser than that. Now, will the time start reducing till you come to a point where you will take 0 hours to make one item? No. After a while, when he or she becomes very efficient at doing the job, this job becomes a stable value. And this is where you have reached job standard. This is your standard time to do the job. You started, you learned, and now you've reached a standard. This यही पे अपन बोर होने लगते हैं. This is where stagnancy comes into picture in an organization. You are doing the same job for the last 5 years. पहले मजा आ रहा था because I was learning new things. I have learned them now and I'm doing the same thing over and over again. So I am bored. I am bored and now I feel stagnant. So what? You want to switch. You want to go to a new organization, do new things, learn new things, change a profile. But your organization looks at it as somebody who is very efficient at doing something. इसको जाने मत दो. ये बेस्ट काम करता है. किसी कोई और आएगा तो वापस इधर से चालू करेगा. यहाँ पहुंचने में उसको 2-3 साल लग जाएंगे. ये पहुंच गया ऑलरेडी तो इसको पकड़ के रखो. But you don't want to work because you are bored. So what is what do you call it? Efficient for your organization is boring to you. I've been doing this over and over again and now I am bored. Whatever it is, this is how learning curve works. So to sum it up, what happens in learning curve is when you do the same job repeatedly, when you repeat the same job over and over again, what happens over time is you become more and more efficient in doing the job, and more efficiency is lesser time. And that is how learning curve works. Let's start taking practical examples or examples that we are going to do in questions. Every kind of an organization. Now what do I mean by kind of an organization? मतलब financial organizations होती है, research based organizations होती हैं, production based organizations होती हैं. Every kind of an organization has a certain learning to it. मतलब कोई भी काम करे ना तो एक रेट से लर्न करता है. हाँ, there are some people who are super intelligent and super quick, they learn very fast. There are some people who are slow, so they take slightly longer, but एक standard rate of learning होता है. So let's say आपकी production based firm है. What is a kind of a firm? Production based firm. And you are making, let's say you are making tables. आप टेबल्स बना रहे हो, तो एक वर्कर एक टेबल बनाता है, चालू करता है, finishes the table and then starts making a new table. And we've realized that to make the first table, it took 100 hours. Previous experiences and previous knowledge says that this kind of a job has 80% learning. What does that mean? Well, what that means is when that person repeats this work means makes one more table. So total how many tables made? 2 tables. Let me repeat this. When this person repeats the job meaning makes how many tables? 2 tables. The average time per job now will become 80% of what it was originally. What was it originally? 100. 80% of 100 is 80 hours. Let me repeat this and then I'm going to clarify a few things. आपने पहला यूनिट बनाया, so number of units, it took 100 hours. Now when you made one more unit, so total number of units was 2, the first and the second, you repeated the work. And when you repeated the work, the total number of units that were made were 2. The average time for these 2 units is 80 hours. Matlab, first unit took 80 hours and second unit took 80 hours? No. Both together on an average took 80 hours. Okay sir, तो total कितना लगा? बताता हूं. एक का 100 तो एक का 100. 2 यूनिट का एवरेज 80 तो 2 यूनिट का टोटल 80 into 2 which is 160. I want you to understand something. ये जो 2 यूनिट बनाए एवरेज 80 लगा, मतलब टोटल 160 लगा. इस 2 यूनिट बनाने में टोटल 160 आवर्स जो लगा है उसमें पहला यूनिट बनाने के लिए 100 आवर्स लगा और सेकेंड यूनिट बनाने के लिए 60 लगा. ऑन एन एवरेज 80 आवर्स लगा. I will repeat this. You made the first unit, it took 100 hours. Such kind of a job has an 80% learning to it. If such kind of a job has an 80% learning to it, when I repeat the same work, so I made 1 unit first, when I make 1 more unit, I'm repeating it. The total number of units is 2. There's a reason why I'm saying repeating the job. Total number of jobs is 2. The average time taken to make these 2 jobs is 80% of the first average. Learning is always applied on average time. 80 on an average for 2, so total is 80 into 2 which is 160. Now listen to what I am saying carefully. If I repeat the same job again, what am I doing? Repeating the same job. What does that mean? How many articles have I made? 2. So if I am repeating, how many more do I need to make? 2 more. Repeat the same job again. When I repeat the same job again, which means I make 2 more units, original 2 plus this 2, 2 plus 2 is 4 units. The average for the 4 is going to be 80% of the previous average, which is 80, and 8 8s is 64 hours. On an average, 64 hours for 4 jobs, then the total will be 64 into 4. 64 into 4, 256 am correct? Yes. The total time is 256 hours. What if I repeat the same job again? What does that mean? You have made 4 units. Repeating the same job meaning making 4 more units, which is 4 plus 4 is 8 units. And the average time for 8 units will be 80% of the 64. 80% of 64 should be 512 if I'm correct. So 5.14. 64 into 80% is 51.2 is 51.2 hours on an average. Total will be 51.2 into 8, which is 409.6 hours. And this is how learning curve works. Check. For the first unit, it took 100 hours. So for 8 units, it should take 800 hours. That is how we function, right? I find out that there is a learning here, and because there is a learning here, the time taken will keep reducing, and it will not actually take 800 hours in total. It will take 409.6 hours in total. Let me repeat this. For one job, if it takes 100 hours, double the work. Repeat the same work again. So 1 plus 1 will be for 2 units. It will take 80% of 100, which is 80 hours on an average. For double the work, which is 2 plus 2 more is 4 units, it will take 64 hours on an average, which is 80% of the 80. And if I repeat the same job, which is 4 units, plus I repeat it by making 4 more units, I will again learn more, and that is why the time taken will again become 80% of what I took for doing the first 4 units, which is 51.2 hours. Every time I double what I was doing, every time I repeat whatever I was doing, I learn by a certain rate, and that rate here is 80%. And these are the kind of questions you are going to have in learning curve. Well, they will tell you, or they will ask you that you are doing something. The first unit requires so and so hours. Can you tell me how much time will it require to make 4 units? How much time will it make to require 8 units? 8 double, 16 units. 16 double, 32 units. 32 double, 64 units. They can ask you any of this. You keep doing the average and doing the total, and that is what you get. So what do I need to tell you? I need to tell you how much time it requires to make the first unit and what the learning is. If I tell you that, then for a given number of units, I can tell you what the average time is. That average can be made total, but first I can find the average. Let's look at questions now. Let's start with questions. I'm directly doing questions from your institute material. I'm not doing anything else. I want you to directly come to, question number 2, which according to me is page 200 in your module. Question 2 as well. What does the question say? The question says, learning curve as a management accounting has now become or going to become an accepted tool in the industry. For its applications are almost unlimited. When it is used correctly, it can lead to increased business and higher profits. When used without proper knowledge, it can lead to lost business and bankruptcy. So if you understand it well, it will give you profit. If you don't understand it well, might be a problem. State precisely your understanding of learning curve and the theory of learning curve, the areas where learning curve may assist in management accounting. So all this is whatever I have said up till now is written in proper in proper language, in textbook language, in finance based language, a little before these questions are put. So a little before, somewhere around page 195 is where all this will be put. I'm starting with practical questions, and the question starts here at 4. Sorry, what does the question say? Well, the question says, which starts from 4, illustrate the use of learning curves for calculating expected average unit cost of making 4 machines and 8 machines. So what are you doing? You are making machines. Okay. Using the following data. What is the data? Direct labor needed for the first machine is 1000 hours. So you are making machines, and to make the first machine it took 1000 hours. Correct? Learning curve is 90%. So there is a 90% learning in this kind of a job. Labor cost is rupees 15 per hour. Material cost is rupees 1,50,000, and fixed cost for either size of the order is 60,000 rupees. So you are making machines. The first machine took 1000 hours. They are asking you the average cost for making 4 machines. What is given to you? Labor cost per hour, material cost per unit, and fixed cost for all the units, which is for an order, which is either size of the order, whether the order is a 4 unit order or an 8 unit order. I need to understand that to calculate the costs, I need to know how long is it going to take to make 4 machines and to make 8 machines. So let's start with doing that. Let me get rid of the question by writing down the basics of the data. Should I write it down here? I think yes. So I'm writing down direct labor is 1000 hours. Learning is 90%. Labor cost is rupees 15 per hour. Direct material is 1,50,000 rupees per unit, and fixed cost for either size of the order. So whether you order 4 units or you order 8 units, could be that this is a transportation cost. तो टेम्पो में मैं 4 मशीन डाल के भेजूं या 8 मशीन डाल के भेजूं, लगने वाला तो 60,000 रुपया है. Let's get rid of this. Let's begin with the question. So I have to find the cost to make 4 machines and 8 machines. I need the time taken to make 4 machines and 8 machines. So the first column that I'm going to write is, I'm going to say number of machines. Correct? After number of machines, I'm going to have average time per machine. I'll tell you why I'm writing it so cramped up, because I have to do the calculations here itself. So number of machines, first machine, I'm leaving a right line and writing, or let me start here. First machine, second machine. First machine takes 1000 hours. Correct? On an average. Now, when I double the work, the average time will become 90% of what it was originally. Originally it was 1000 hours. So on an average, I will take 90% of 1000, which is 900 hours. What happens when I double the work, which is 4 2s are 8, 2 plus 2 is 4 machines. When I make 4 machines, it will take 90% on an average of 900, which is 9 9s are 81, 810 hours. What happens when I double the work? When I make 4 more machines, 4 plus 4, 8 machines, the average time to make 8 machines will be 90% of 810. What is the 90% of 810? It is 729. So it will take 729 hours on an average. And I told you this. You tell me how long does it take to make the first unit and you tell me what the learning is, I will give you the average for 2, 4, 8. I could give it for 16, for 32 and so on. But right now we only want for 4 machines and 8 machines. So we stop here. Now they want you to find out the total cost, or rather the average cost to make 4 and 8 machines. Well, I'm not going to find average cost. You know what I'm going to do? I'm going to find total cost. For total cost, I need total time. So after average time, total time. 1 on an average is 1000. So 1 in total is also 1000. 2 on an average is 900. 9 twos are 1800. 1 on an average is 810. So 4 will be 810 into 4. 8 fours are 32. So 3240 if I'm right. 810 into 4 is 3240. Perfect. 1 on an average is 729. So 8 will be 729 into 8. 5832 hours. 5832 hours. So let me repeat that for you. One machine on an average, or the first unit, took 1000 hours. So like I told you, I'm going to apply the learning curve when I double the job. When I make one more, 1 plus 1, 2, I will take on an average 90% of the first, which is 90% of 1000, which is 900. When I double that again, 2 plus 2 is 4. Is going to be 90% of the 900, which is 810. When I double this and make 4 more, which is 4 plus 4, total of 8. On an average, I will require 729 hours, which means total I will require 5832. See, technically when 1 took 1000, 8 should have taken 18,000. But 8 don't take 18,000, 8 take 5832 hours. Total time is done. Let's start doing cost. That is labor cost. Labor cost is rupees 15 per unit. Correct? So for 1000 hours into 15 is 15,000. For 1800 hours, 1800 into 15. 27,000. So it's going to cost me 27,000 to make 2 machines, labor wise. For 4, the total time is 3240. At 15 rupees an hour, what is it going to cost me? 3240 into 15. 48600. So it's going to cost me 48600. The total time required to make 8 machines is 5832 hours. 5832 hours. At 15 rupees per hour, I will end up paying 87,480 rupees. So 87,480 rupees. Am I correct? Yes. Let me draw a line here so that there is no confusion. I am done with the labor. What is next after labor? Material. What is material? 1,50,000 per unit. Now see, material has nothing to do with learning. Like for example, if I want to paint a particular house, no matter what the time taken is, the amount of paint required will be the same. So when an experienced painter does it, he or she might do faster. When an inexperienced painter does it, he or she will take longer. But the total quantity of paint will remain the same. No, to make a chair, if it takes 10 feet of wood, no matter who does it, I will require 10 feet of wood only. It's just that an experienced person will do it faster. Inexperienced person will take more time. So material will remain the same for all. 1 unit, 1,50,000. So 1 unit will be 1,50,000. 1 unit is 1,50,000. So 2 units will require double the material, so 3 lakh. 1 unit is 1,50,000. 4 units will require 4 times 1,50,000, which is 6 lakh. 1 unit is 1,50,000. 8 units will require 8 times that, which is 12 lakh rupees. This is material. Let's come to the next, which is fixed cost. Now, no matter what order size is, fixed cost is the same. So, no matter what size you order, I am always charging you 60,000. I have all my costs, labor according to the learning hours, material and the fixed. Can I now find a total? Yes. The total cost will be 15,000 for the labor plus 1,50,000 plus 60,000. So 15 plus 1,50,000 plus 60,000. 15,000 plus 1,50,000 plus 60,000. I get 2,25,000 rupees. So the total cost of making 1 unit is 2,25,000 rupees. For 2 units, it is going to be 27,000 plus 3 lakh plus 60,000, which is 3,87,000 rupees. 3,87,000 rupees. Next is 48,600 on the labor. So 48,600 on the labor plus 6 lakh on the material plus 60,000 on the fixed, which is 7,08,600. So 7,08,600. Let's come to the last one. 87,000 on the material. Sorry, 87,480 on the material. Sorry, on the labor. 12 lakh on the material and 60,000, that is the fixed, is 13,47,480. 13,47,480. Now the problem is I don't have space for average. So what I'm going to do is I'm going to take a new piece of paper and just extend the page to make it match there, because I don't want to write it below. Please, you make sure that you write it properly, and this is where I'm going to continue with the average. So 1 second. So after the total, the next column that I'm doing is average. 2,25,000 for 1 unit is 2,25,000 1 unit. That doesn't change. Average is for 1, so remains the same, 2,25,000. 387,000 for 2 units. Then on an average, what will I require? Let me check. 387,000, divide that into 2 parts, is 193,500. So on an average, 193,500. Next, 7,08,600 for 4 units. So 7,08,600 for 4 units. So per unit cost is 1,77,150. 1,77,150. And lastly, 13,47,480 for 8 units. So 13,47,480 for 8 units is going to be 1,68,435 per unit. And that's my answer. For 4 units, the average cost is 1,77,150, and for 8 units, the average cost is 1,68,435. Let me quickly repeat this for you. What am I doing? I'm making machines. I have to find what is the cost in making 4 machines and 8 machines. So for that, you need to tell me how much time does it require to make the first machine and what is the learning. Well, the first machine requires 1000 hours and the learning is 90%. So as work doubles, the average time will become 90% of the previous. So as 1 doubles and becomes 2, 1000 will become 90% and become 900. As 2 doubles and becomes 4, the average time will become 90% and become 810. As 4 doubles and becomes 8, the average time will 90% of 810, which is 729. From the average time, I found the total time. They want you to calculate cost. They've given you 3 costs: labor, which is 15 per hour, material, which is 1,50,000 per unit, and fixed cost of 60,000 no matter what the order is. So what I start doing is I start calculating the totals and say 1000 hours at 15 rupees is 15,000 rupees. 1800 hours at 15 rupees is 27,000 rupees. 3240 hours at 15 rupees is 48,600 rupees, and so on. This is the labor cost. Material will directly multiply because learning does not apply on material. You don't save material when you learn. You save time when you learn. So the first unit required 1,50,000 unit per unit. Then 1 will require 1,50,000, 2 will require 3 lakhs, 4 will require 6 lakhs, and 8 will require 12 lakhs. No matter what is the size of your order, the fixed cost remains 60,000 rupees. So the 60,000 is a fixed cost. The total is a total of all of this. And when I average it, I will get the average cost. The average cost for 4 machines is 1,77,150. So average for 4 and average for 8 machines is 1,68,435. That is what they were expecting. So I'm going to say average cost of 4 machines is rupees 1,77,150, and average cost for 8 machines is 1,68,435 rupees. That's it. Let's see what they've done in the institute material. So what they've done in the institute material is they've kept everything as average and calculated. See, I'll tell you. What I did is I got the average. From the average I took a total. No. They kept average time. They multiplied the average time by 15. That is why they have taken the material cost for only 1 unit. Because anyway we want average only, right? After that, they have kept the order for 1 unit as 60,000 and total. Now for the second, 900, I made 900 as 1800 and then multiplied 1800. They have kept it as 900 because they are doing it on average only. They are not doing it total and then average. I have done total and then average. Material is 1,50,000 because they are doing this for 1 unit. And fixed cost. See, if it is a 2 machine order, I am going to charge you 60,000 for 2 machines. So on average for 1 machine, I am charging 30,000 and then the total. So they don't have to do a total and then an average. Their answer itself is the average. What I want to say is, isn't our final answer in both cases the same, which is 1,77,150 and 1,68,435? As long as that is the same, nobody really cares about how you finish off the question. So for 4 machines, 1,77,150, perfect. For 8 machines, 1,68,435. So what happens is, once you calculate the average time, then the calculation will differ. After that, what do they want you to do? Sometimes they give you cost, sometimes they don't give you cost, they only ask you to find time, and so on. But this is it. This is the main frame. You have to tell me how long does it take for the first unit, and you have to give me the learning. Here it was 90%. So 90%, 90%, 90% as work doubles. So this is the average time that I get from the learning curve and the time required to make the first unit. That is the first question that I wanted to do. Let's come to the next. The next question is going to be, this was question number 2, right? Yes, the next question is going to be question number 4, which in your material is more page 203, question number 4. What does the question say? A firm received an order to make and supply 8 units of a standard product, which involves intricate labor operations. So a firm has to make 8 units of a certain commodity, which requires a little complicated work. Why are they saying that? So what happens is, when you're doing complicated work, when you repeat it over and over again, it becomes less complicated and then efficiency increases. The first unit was made in 10 hours. Fantastic. It is understood that this type of labor operation is subject to 80% learning rate. So although the first unit took 10 hours, this kind of work is subject to 80% learning rate. The workers are getting wage rate of rupees 12 per hour. What are you expected to do? Number 1. What is the total time or labor cost to execute the above order? What is the above order? Well, the above order is a firm received an order to make and supply 8 units of a standard product. So that is my above order, 8 units. What do they want? What is the total time and labor cost required to execute the above order? Fine. You have given me the 2 things that I basically and mainly require, and the 2 things are, number 1, what is the total, what is the time it takes to make the first unit, and number 2 is what is the learning rate. So let me write that down. Time for the first unit is 10 hours. And learning is 80%. Labor is rupees 12 per hour. So let's start. Here there's only labor, there is nothing else. Fantastic. You want me to find the cost to make 8 units. Okay. So I'm going to say number of units and average time. First unit took 10 hours and the learning is 80%. Then when I double the work, 2 units will on an average not take 10 hours, will take 80% of 10, which is 8 hours. So 2 units on an average will take 8 hours. 4 units, when I double the work, will be an average of 80% of 8, which is 8 8s are 64. So 6.4 hours. And when I double the work and make 8 units, it will take 80% of 64. That is going to be 512 if I'm correct. So 80% of 6.4 into 80% is 5.12. So which is 5.12 hours. This is the average time it is going to take to make 1 unit, 2 units, 4 units and 8 units. What is the total time? Total time will be 10 into 1, which is 10, 8 into 2, which is 16 hours, 6.4 into 4, now 6 4s are 24, I think 256, So 25.6 hours. Let me be sure. 6.4 into 2. 6.4 into 4, sorry, is 25.6. 5.12 into 8 is 5.12 into 8 will be 40.96 hours. So 40.96 hours. So number of units, average time, total time. What do you want me to find? Cost, no? At 12 rupees per hour for 10 hours, I am going to charge you 120 rupees. At 12 rupees per hour, 16 hours, I am going to charge you 16 into 12 is 192 rupees. At 12 rupees per hour for 25.6 hours, I am going to charge you 307.2 rupees. And at 12 rupees per hour for 40.96 hours, I am going to charge you 491.52 rupees. So it is 491.52 rupees. Let's see if that is their answer. 491.52 rupees. The answer to the first part. So they've found the time, they haven't found the cost. Let's come here directly. The labor required for 8 units is 40.96 hours. Perfect. So the cost is 40.96 into 12, which is 491.52 rupees. Perfect. That is exactly what we have also, 492.51. Sure? Yes, 492.51. Let's come back and go to the second question that they've asked. What have they asked? The second question that they asked is, if a repeat order of 24 units is also received for the same customer, what is the labor cost necessary for the second order? Okay, now there is a problem. Why is there a problem? Well, there is a problem because I'll tell you, the problem with my learning curve or learning curve in general that I have learned is that I can give you the cost of 1 unit or the time of or the average time or the total time or the total cost or the average cost of 1 unit, 2 units, 4 units, 8 units. Double of 8, 16 units. Double of 16, 32 units. Double of 32, 64 units. Double of 64, 128 units. Double of 128, 512 units. Double of 512, 1024 units. And so on. I can't give you intermediate. If in the same question you would have asked me, sir, can you tell me what is the total cost for 5 units or for 6 units or for 7 units, my knowledge ends there. I can't tell you that. You ask me for 1, double it 2, double it 4, double it 8, I can tell you. I can't tell you for any other units. Is this clear to everyone? And that is why when you ask me for 24 units, I can't do. Because 24 doesn't fit here. When I double 8, I get 16 units. When I double 16, I get 32 units. 24 will lie somewhere here and I can't tell you for intermediate. You ask me the cost or the time, whether average or total for 1, 2, 4, 8, 16, 32 units. Don't ask me for 24. But can I tell you something? They've not asked you for 24. Read the question properly. If a repeat order, very important, repeat order of 24 units was received from the same customer, what is the labor cost necessary for the second order? See, for the same order there is a repeat. So the 8 units that I have made, in the same order I have to make another 24. Then can I say my learning for the first 8 will carry to the next 24. I don't have to start from 1 again. It's the same article that I'm making. If it's the same article that I'm making, my learning of the first 8 will help me in the next 24. And can I ask you something? You have made 8 units or the first order of 8 units. When I add a repeat order of 24 units, how many units does it become? 32. So are they actually asking you intermediate? No, they are asking you for 32 units because after 8 the learning will continue for the next 24. So after 8 when I make 24 units, I have made 32 units of the same product, and for 32 I can give you the cost or the time, whether average or total. So you see how they've disguised the question into you thinking that, oh, this question I can't do. Where is the keywords? The keywords are a repeat order of 24 units is received. This will tell you from the same customer. This will tell you that after it you are making 24 of the same product. You are not making a new product. If it was a new product, new learning would begin. New total cost would be applied. Here it is going to continue. Find the cost of the necessary second order. Fine. Let me do one thing. When you say that after 8 I am making 24 more units, which means I am making a total of 32 units. I can give you the total time it requires to make 32 units. How? 16 units, I will take 80% of 5.12. What is 80% of 5.12? 4.096. So this is 4.096 hours. And for 32, I am going to take 80% of that. So 80% of 4.096 will be 3.2768 hours on an average. 3.2768 hours on an average. So if the average is 4.096, the total will be 4.096 into 60 is 65.536. 65.536 hours. If the average for 32 is 3.2768, then the total will be, well, the total will be 3.2768 into 32 units that I'm making, which is 104.8578. So this is 104.8578 hours in total. 857.6 hours in total. 104.8576 hours in total. Done. Now the next thing is very important. They have asked you, read the question properly. If a repeat order of 24 units is received from the same customer, what is the labor cost of the necessary second order? They are not asking you the cost of all the 32 units. They are asking you the cost of these incremental 24 units that you made. If you multiply 104.8576 by the 12 rupees per hour, you will be giving them the cost of 32 units. They don't want the cost of all 32 units. They are saying that the repeat order that I gave you of 24 units, give me the cost of that. Then can I say I need to find only the time of those 32 units? Of those 24 units? How am I going to do that? Simple. Can I say the total time it takes to make 32 units is known to me? What is the total time? The total time is 104.8576 hours. But in this, it took me 40.96 hours to make the first 8 units. So in these 32, the first 8 units took 40.96 hours. Then can I say whatever this extra pending is, whatever this incremental time you took, is the time you took to make the 24 units, which is 104.8576 minus the 40.96, which is 63.8976. So it is 63. So I am going to say time for repeat order of 24 units is total time for 32 units minus the total time for 8 units. What is the total time for the 32 units that you take? 104.8576 hours minus the time that I took for the 8 units. What was the time that I took for the 8 units? Is 40.96 hours, which is 63.8976 hours. And now calculate the cost. If it took 63.8976 hours for that incremental 24 units, then the cost for repeat order of 24 units is 63.8976 into 12, which is 766.7712 rupees. Let me quickly repeat this question. I'm going to start off by, they've said that you are making an article whose first unit took 10 hours. They are asking you that if there is an order of 8 units, can you find me the total cost? You say, okay, I will find you the total cost. First unit 10 hours, then double. So the average time for 2 units will be 80% of the 10, which is 8 hours. Double, the average time for 4 units will be 80% of 8, which is 6.4 hours. Double, which is for 8 units, the average time will be 80% of 6.4, which is 5.12 hours. If this is the average time for 8, the total time for 8 is 40.96. So the cost for those 8 is 491.52. Then they've done something very intelligent. They have said that if a repeat order is given to you of 24 units from the same customer, so the same customer is repeating an order of 24 units. So you will think to yourself, oh, this I can't do, because 24 units I can't do with my logic of learning curve. You can ask me for 16 units for 32, I can give you. 24 I can't give you. But it's not actually 24. It's a repeat order of the same units. So the learning will continue after the 8 units. After 8, when I make 24 units, I'm technically making a total of 32 units. The total time it takes for me to make 32 units is 104.8576 hours. They want you to find the cost of only the extra 24 units. Then I'm going to say this 104.8576 hours is for all the 32 units. From these 32 unit time, I will have to remove the time it took for the first 8 units, which is 40.96 hours. Once I remove that, I get the time for the incremental 24 units. If this is the time for the 24 units, the cost will be 63.89 into 12, which is 766.7712. Let's see what they have done or how they have written their final answer. This was the first part of the question. See, in the table they've continued up to 32 and they got 104.86. They've stopped at 2 decimals. I've taken up till 4 decimals. That's okay. Next. Labor time for 32 units is 104.86 hours. Labor hours for the first 8 units is 40.96 hours. Therefore, labor required for the second unit order is 63.90. Where did they get this from? From 104.86 minus 40.96 hours. Cost will be the 63.90 into the 12 rupees per hour, which is 766.80. Our answer is 766.7712, which is almost approximately the same. Let me show that to you. So our answer is 766.7712. Their answer is 766.80. So because they've approximated it, they got this as 80 already. You can also approximate and write this as 80. I like to keep it this way. That's it. That is the second question that I wanted to do here. That was question number 4, if I'm correct. Yes, this was question number 4. Now, if you go to question number 5, you will realize that learning curve as a management accounting has become, or it's going to become, if you notice, the same question. It's the same as question number 2. It is the same question as question number 2. It's exactly the same question. They've repeated or they've double printed the question. The final answer and everything, the question asked, everything is the same. So I'm definitely, obviously, yes. The question is exactly the same. It's a repeat of the question number 2. So this is question number 5. And this is what we did some time ago, which is question number 2. It's exactly the same question repeated again. So I'm obviously not going to do the question, and we are going to move on to another question. So with that, I want to stop this session right here, and there are 2 more questions. Those questions I will do in the next session. Thank you very much. Bye. Please make sure you revise and you come to the next session, especially logarithms and the concept of learning curve. Thank you. Bye.